Okay, so I have been looking forward to this actually all week since we announced it. So I'm going to first introduce Aaron, who's one of the co-organizers. Aaron, do you want to just say a little bit about yourself?
Sure.
And
Hi, my name is Aaron Williams. I'm the dev advocate community manager for LF Edge. I had the pleasure of meeting Naeem, as Han said, when him and Eric were coming in presenting to me or to our community about the Mayflower, this autonomous ship. And so, as Han said, reached out and said, "Hey, can you guys give that presentation?" And Naeem wrote back saying, "Hey, I'm also doing this stuff in space. Can I present that?" And that was kind of like the easiest question somebody's ever asked me. Like, of course, please. So, anyways, let me introduce him because I want to hear what he's saying, not me. And so he has the greatest title ever, CTO of space technology at IBM. There at IBM, he leads a number of innovation groups focusing on innovating from the edge, computing in space, to supply chain optimization for space assets, to the autonomous cognitive framework for CubeSat swarms, to the growing challenges of space debris and collision avoidance, then to geospatial analysis with the satellite imagery, and the list kind of goes on. It's absolutely amazing. It's all of us kind of have thought about how these things work and how they would work in space, and he is actually, and his teams are actually doing something about it. So please welcome Naeem, and why don't you take it from here, and I will go hide and actively listen. This is great. Welcome. Thank you.
Well, thank you so much, everyone. Thank you, Hans and Aaron, for inviting me on this forum today. So let me share my deck, share the screen. Hopefully you can see the screen.
Yeah. Yep.
Yes, we can.
All right. Thank you. So yeah, it's like I said, it's an absolute pleasure to be here, and good afternoon, good evening, everyone. So I'm IBM's distinguished engineer and CTO for Space Tech. Been here 21 years, and I started in Tivoli, which used to be monitoring and management solutions 20 years ago, and that was where I had interest for the IoT. And then, if you remember, 10, 12 years ago, we used to have this Smarter Planet campaign from IBM. This was like sort of pre-IoT days, and we got to work on smarter buildings and smarter airports. So basically, the concept was wherever we can, instrument and get information from those sensors and do something with that. And at that time, as you imagine, it was very proprietary stuff, right? It was very hard to get information from these actuators or BMS systems. And today, with the modern technologies, REST APIs, everything is so open, and we can do so many cool things with this. I think IoT is one of my favorite areas to focus on and work in. So I'll take you briefly through, give you an overview of what's happening in space industry in general, and then give you a few use cases what we are working on and where I see the potential. So, all right, let's see. So this is how I have always operated, right? I mean, we should focus on the things which we are really passionate about, and then try to make things happen. So, okay, just a little bit of an IBM. So I'm no stranger to space, and anyone of you guys who follow going back to the moon, the Apollo missions, IBM played a huge role with the mainframes, and 4,000 of IBMers working alongside with NASA to put men on the moon. And I think it's still considered as one of the great engineering feats in the history. And then there's a lot of other stuff which we have done, but I think this stands out. Okay, looking at the global space economy. So I think everybody is probably heard of SpaceX, right? And the stuff which they have been doing for past 3-4 years. The financial institutions like Goldman Sachs and Morgan Stanley, they all have put this up between $1 to $3 trillion industry in the next 2 decades. So there is a there's a huge potential here in next, between now and the next 2 decades here. Space Angels, if you're familiar with that, you can Google Space Angels. They publish these reports for space industry every quarter, and it's free. You can download it. And the last quarter, the equity investments were around 4.5 billion. And this is only one of few industries in this pandemic which is still growing. The landscape which we hear what's happening in this industry, the big thing in space which will happen in next 3 to 4 years is going back to the moon, the RTMS program by NASA, right? So that is a huge project. That's like almost $1 trillion project, and you can imagine the whole ecosystem of that project, right? There's so much opportunity there, and I'll go into detail. And then there's Mars and beyond. We saw this year 3 missions landed, right? And I think last week the Chinese rover actually also landed as well. It was in the orbit since I think February or March timeframe. Then ISS opening up for the commercial private relationships, right? So now private citizens can take a ride to the space station. And then there are many contracts as part of RTMS program where the companies are getting to build these landers and rovers, and we saw SpaceX getting the human lander over there, and then Blue Origin and others are also in the race. Then there is space tourism. So I think we heard that the next Mission Impossible, Tom Cruise will be flying to going to ISS to shoot some of the scenes over there. And then there is like Blue Origin is already started to take orders for people to take to suborbital, which is a little bit above horizon. And then you have the Virgin Galactic, they're also doing, and so on. Now looking at the commercial launchers, the big one, of course, SpaceX. There are other ones, UL, the traditional ones, but I think SpaceX has changed the game. And then Rocket Lab and Blue Origin, many are there. And then related to our IoT stuff today, right? The mega constellations, Starlink, Telesat, Kuiper, OneWeb, right? And this is where a lot of stuff is happening, and I think it will have a great impact on innovation we can do on the ground and in the orbit. So, and please, my screen is in full mode, so I cannot see the questions. So please, if you want to stop me anytime, just stop me and I'll answer the questions.
Okay, yeah, well, I'll monitor the questions and I'll hop in if there's any.
Okay, thank you, Hans. Okay, so let's take a look at what is this industry made up of? What are the different segments, right? I think when I started, I was working with NASA, FTL, and SETI Institute for the last 5 years, and we all we think like yes, it is a rocket science, but we think that this is something totally very high level domain, and we can't there's some special stuff is happening, and we need to have some special kind of degrees and knowledge to get this. But while I was working there, I was like, no, there is room for for us, for software engineers, or for because most of the stuff is going software defined. So that's where I took a lot of interest and say, what, we can, being as a computer science person focused on cloud and typical traditional stuff, we can also venture into what's happening in the space industry. So if you look on the top, you have these large rocket launchers like SpaceX, ULA, and others, right? And there's a category of these: big launchers, small launchers, and others. And then there's a CubeSat. So CubeSat is getting very popular. Basically, CubeSat, small sat, an easy analogy which we can understand in our areas is like microservices, right? So a few years ago, we used to have these monolithic products, right? Big ones takes year to build, and then a lot of money involved and time and all that stuff. With the microservices, we can build small components. We don't have to wait for the whole big thing, and it's sort of disposable. We can build small pieces as we need, and so forth and so on. Same thing with CubeSats. CubeSats are a small version of a larger satellite, right? These things can be built for a very professional one, can be built under $1 million. And whereas your larger satellites are $300 to $400 million, which takes years to build. CubeSat you can build within 6 months, and in 1 year you can launch them. And you can probably have watching many companies are emerging in this area, launching these small sats. And since the technology is so advanced, and basically most of these companies are doing Earth observation. So they have these very fancy cameras over there. It's doing Earth observation, and there is enormous amounts of use cases with the Earth observation. So that's one area. Satellite manufacturing, of course, on the hardware side. The network providers will talk about that, 5G access, IoT networks, right? So there are many companies like, for example, Fleet.space. So if you are in your remote areas from agriculture, a precision agriculture point of view, and you want to, monitor the health of your crop and what stuff and water and all these things, drought stuff, you can have sensors, you can have LoRaWAN gateway connected there, sensors talking to the gateway, and then that gateway beaming up information via satellite to wherever you are on-prem, in cloud, wherever it is, right? So that's a way of, how these satellites can connect with the IoT networks. And that's where I think with the 5G and these Starlink and, these satellites, these MAG constellations will be helpful, where we don't have to rely on on the ground kind of fiber, which takes time and costly, right? We can just beam up and let the satellites handle that, which is giving you almost equivalent or faster speeds. And then the other area from the computer science point of view, right? The data analysis. This is a huge area. I mean, if you go and look at what Planet and Maxar are doing, right? This is amazing stuff. The kind of resolution they get is like 50 centimeters. They can see almost everything from the low Earth orbit. So taking that information and fusing it with the information you have on the ground, and if you're looking at the supply chain optimization, there's an enormous amount of things we can do. And we'll talk more about these use cases. Okay, so let's talk about the the use case. Let's deep dive into this. So we connected with the space station folks last year, and we are looking for how we can do edge computing, in the space. What are the opportunities there? As you know, the space station is like a laboratory, right? It's many countries are involved, and they encourage where countries can, do work with them. They can run experiments. There are many experiments which run on the space station on a daily basis. So it's like a community thing. So we reached out, and they say one of the hot projects there was this DNA sequencer which they run. So there's this MinION device which is on space station, and what happens? These astronauts at whatever given interval, they take these the sample from the surface of inside the space station, and they're looking for microbes. So they run it through this device, and then this device generates like almost half a terabyte of information. And now what happens, the information has to come down to the ground, and the speeds, you probably will be surprised. The speeds are not as fast. Even it's probably not even as fast as we have at home, the connectivity between the space station and on the ground. And on top of that, that bandwidth is shared by many other groups. It's not only just, I'm running my stuff. A lot of stuff is happening between the station and the ground station on the Earth. So, we said, okay, how about we do all this computation? The data comes down, the computation happens, and by the time the PI, the principal investigator, requests for this information and they got back the results, it's like a couple of months have passed by. So we're like, okay, how about we do all this processing? At the end of the day, they're looking for a PDF file, a result file. That's what they're looking for, a file which is like maybe less than 2 meg. And so HPE has this SBC2 space-borne computers, which they've been sending for, I think, last 5 or 6 years. They just sent a second update version in February. So we partnered between us, HPE, and NASA, and we said, we have this project from NASA for DNA sequencing. ISS, of course, has their space station. HPE, can we work together and leverage your compute power? And then we brought our code and our platform. So we took the Red Hat Code Ready container. Basically, it's a miniature version of an OpenShift platform, a Cube platform, a single node. So we took that lightweight Cube platform, and we took the code, which is used to do all this processing of information. We containerized the code. We packaged this whole thing up, and we sent it on February 18th. The ULA took it up there. Last week, the systems are live now, and we are going to do our first live test next Thursday, because they give you a window of like a couple of hours every week. So we'll have our slot on next Thursday to run this experiment, do a test run, and then we will do an actual DNA whenever our turn comes. So that was I mean, and this whole thing, the edge computation, it took like 6 to 8 hours, and after that whole run, the file generated is like a 2 to 3 meg file. So now I can reduce those couple of months to like literally in a week or in few days. Since we start the run and we get that run done, we can get the PDF down to the PI. So I mean, that was the the idea of the edge computing in space, and we also got the containers, which the Red Hat team was very happy, and they can claim that they have their first the containers in space. But that opens up doors for many other things, because like I mentioned, there are many other experiments happening. So there's another group in NASA based in Florida who are looking at the health of plants, because to grow plants in the space as we go towards the moon and Mars, and they want to use AI to look at the health of these plants and monitor that. And that then again, this is a perfect edge computing solution where we can just push the model and it can do inferencing and figure it out, watch the health of this plant. So that is we just this was one of the big projects we finished last year. Besides, we were in parallel working on that Mayflower stuff. So this is one thing. Okay. If no questions, I'll move to the second. Okay. So now if you're in the space stuff, by the way, this is if you Google Leo Labs, just type Leo Labs platform, and you will get this live portal, and you can see what's happening in real time in our orbit. So just to give you a little bit of background here, right? So we have 3 orbits, above above the Earth, right? So we have low Earth orbit, we have middle Earth orbit, and then we have the GEO. So Leo ranges between 100 to 1,000 miles. And normally you have like the mega constellations like providing internet data, voice services, and then this Earth observation satellites. Then you have the MEO, which is GPS, and much of the the military stuff or stuff is happening in that, which is around 6,000 to 12,000 mile orbit. And then you have the GEO, where a good example is satellite TV. So that is around 22,000 miles. It has to be an exact range because it's in rotation with the Earth. So that's why when you are watching your sports fight and you have a dish outside, you don't have to run outside and move your dish because it's in sync with the GEO satellites. And so these are the 3 orbits. Now most of the activity is happening in the low Earth orbit. So if we just look at in general, in last 50 or 60 years, we have launched like 9,000 satellites, and 5,000 of them are currently orbiting, and 2,000 of them operational. And but you look over here in this picture, this is like debris. This is like stage 2. Unlike SpaceX, which brings their stages down, right, which lands them, which looks like a sci-fi, right, how they do that stuff. But most of the players, they just throw their stuff in the orbit and just and it's just floating over there. And this is what you're looking at, this debris, right? And this is just like big things. And then there's debris. There's like 34,000 objects which are greater than 10 centimeter. And if you recall, just 2 weeks ago, when this Dragon crew went up, midway in their flight to ISS, there was an alert which came from the Air Force saying that there's a debris coming towards the Dragon, and they actually went into their pressurized suit in case something happens, right? This is how serious this stuff is. And then later on, of course, after a day, they said that was a false alert. But anyways, true or false, there is a lot of this stuff happening in the orbit. And so now imagine what mega constellations are trying to do. So this is what it looks like today. In next 5 years, if everything goes to the plan, SpaceX, as you know, do their launch every 2 weeks, and they launch this pack of these 50 to 60 satellites. So they're up to like 1,500 plus these Starlink satellites. They want to put around, they say 12,000, but around between 12 and 24,000 of these satellites they want to put in next 3 years. Now imagine that number, right? And how much we have done in last 60 years and how much will be done in next 3 years. Then there is this Amazon Kuiper. They want to put like 3,000. GW, which is still unknown, sort of a new core company from China, they got approved for 13,000 because they want to now, they're in the space race, and they want to even go and have their own GPS systems. Then OneWeb, which wants to put 2,000. So we are looking at like maybe 30 to 40,000 satellites going up in next 3 to 5 years. So so that's, I mean, technology is good, but we have to be, we have to watch out for the Earth also, right? I mean, what we have done with the oceans, let's not destroy the night sky, right? Like for us, we who are amateur astronomers, now imagine you have these gigantic telescopes sitting in the South America, Peru, right over there, and Chile. They are already screaming. They are saying that this is creating a lot of noise in their data. So I don't know if you guys have seen Starlink satellites. If you can just uh, there are so many websites you can see, when it's a flyby based on your location. This is like a train of reindeers which goes for like almost 3 to 5 minutes, and you will see these satellites are passing by, right? So if you're doing deep space observation from these big radio telescopes, now you are getting a lot of this data inside it, noise inside your data, right? So yeah, Starlink is saying we are going to reduce the reflection, all that stuff, but we'll see, right? So anyways, this area is a huge concern. And this is where you will hear things like space traffic management, space situational awareness, space debris, all these things. So we are working with some faculty here at UT Austin, with a professor Moribaja, and he's one of the well-known authorities in this area. So we work with them to open source the code for space situational awareness, basically looking for the orbital prediction or conjunction search and for light pollution prediction, right? Especially for people who want to do deep space, they want to know what's the clear window for them at any given night. So the code is open source on IBM's GitHub. So, but this is where if you're talking in from the military or defense and DoD side and Air Force, this is a very, very hot topic in the industry because so much stuff is happening in the orbits. We want to now have a better idea what's there, so we can do better planning and stuff. And but right now what it needs is like a collaboration between the governments to come up with a plan, because right now it's like a wild west. Anybody can just go and put their stuff in, and I don't know what they are waiting for. But okay, CubeSats. So like I mentioned, the CubeSat, right? It started like from the universities in California as a project where universities and students can build these CubeSats, launch and do some in experimentation. But now it has gone like commercial, like where companies are emerging and they are going with these small sats, CubeSats, nanosats, and doing, and especially with the IoT stuff, there is a lot of uh, relevance here with these CubeSats. So what we last summer we got some interns and we said let's build an open source project where think of the swarm of CubeSats. And this can be swarm of drones or anything, right? So let's say if we have a swarm of these CubeSats and we take the concepts of distributed computing and mesh network, and they are like, in a given proximity, an alert comes from the ground station. It says there might be a big hurricane coming in the Atlantic. Go and start watching this event. So then this framework, this CubeSat, which are part of this framework, dynamically they can determine who has the capacity to take on this job, and then once the event is happened, they offload. So basically, sort of cloud distributed computing, but autonomous, intelligent, where it's determining what needs to be done and who has the capacity to do what. So this project is also available on IBM's GitHub open source. So. But I see there's a very interesting conference which happens every summer in Utah about the small sat. So if you guys are interested, take a look at that. There's a lot of very novel, neat ideas people are putting. And I think from IoT point of view, if there are many startups emerging, there's a lot of cool things we can do with the IoT and the CubeSat. The other area which I work with the NASA FDL, Frontier Development Lab in SETI. So every summer they run some interesting projects, and we get to pick what we want to look into. And so this year we are looking at space weather impact on Earth. Basically, so there is as you know, so on Sun there's a solar activity, and when that activity happens, it flows towards the Earth. And that's where you, on the northern side, if you're up there, you see sometime these auroras if you're up north. because those they are interfering with either the north or the south pole, the magnetic, and it creates all these beautiful lights at night. So, but in the middle, you can see you have orbits, right? We have the Geo, Meo, Leo, and there's a lot of stuff there. So you often hear that when there is a solar activity, that you might lose your GPS functions, or the cellular networks might be down. Even the grid can be affected by that. So this summer we'll try to see, okay, what's the impact of this solar activity on the satellites itself? Because if it can do damage to stuff on the ground, it must do damage to the electronics on the sats also, even though they have the radiation hardening, everything else, but still. And as you know, to maneuver a satellite is like the last thing they want to do, because it has limited fuel on it, right? And every maneuver takes a bit of it. So you don't just maneuver stuff, just for it. You only maneuver at the last resort. So one thing I think, just to mention about that, when I was talking about the space debris thing. So last year, International Space Station had to maneuver 3 times. Now imagine if space station is an expensive, to do that, the space station itself, the satellite is expensive. The space station had to maneuver 3 times because there was debris coming in its path. So this is how serious that matter is. Okay, the other thing, while working with space station, this is more on the AI and ML side. Because of the microgravity, stuff is constantly moving as well inside the space station. So when we were discussing with them, they say sometimes they will put their tools or stuff, they will put inside the space station, and next time they want to go and see, it's not there because it has floated somewhere else. And if you have seen some videos of space station, things are floating. Even when they are doing their live presentation, you will see some stuff floating in the background stuff. So they wanted us to build an AI model which can detect the floating objects and determine what that object is, and then of course alert on that. So we did this proof of concept with them in December. Okay, looking at some other technologies. So blockchain. So the aspect of blockchain which I like is the immutable aspect, right? So that's the other thing. All the other stuff around it, processes, I think it just makes it very complex, and that's why it hasn't. I don't think it has taken off yet. I mean, we have 2 big use cases. One is for the food trust, and one is for the shipping containers. But still, I think it's a little bit complex, and trying to bring multiple people on table and to agree on something is challenging. And over here, we're talking about organizations. But anyways, just to give you an idea, so let's say we are talking about satellite manufacturing, space cargo, which goes very often up, space traffic management, where you have to share data between different agencies. How can blockchain work, right? So blockchain is good, when you have a consortium, right? So you can show that, provide the trust, transparency, and the provenance aspect. So if you're looking at, let's say, satellite manufacturing, it's a very complicated process, right? So, let's say a company, let's say I ask a company, go and build me a satellite. That company has its suppliers, subsystem contractors, and they're doing the work. There's a lot of testing and where the parts are coming from. You need to have visibility into that whole thing. In case something goes wrong tomorrow, can I trace it back all the way from this one small component which was part of this satellite, where it came from? I think in 2019, SpaceX caught a company which is their suppliers or subsystem contractors. They were forging signatures. So in this industry, if one launch goes bad, you're almost out of business. So yes. So that anyway, so that's satellite manufacturing. Then you have the launch service provider like SpaceX. You have mission control. You have satellite operators. Then you have insurance companies. You have the regulatory authorities, right? So you can imagine how complex this whole system is. Even though it looks SpaceX has made it look so cool, right? It just goes up and they put stuff in the orbit and things comes down and everything is good. But behind the scenes, it's a very complex, process. So I think this can be successful in this industry if the FAA, FCC, government authorities mandate that. When all these companies were trying to put stuff in the space, they need to digitize their process so we can have full transparency. Because for blockchain to work, the promise is to that you reduce the amount of paper processes, right? It has to be digitized, so I can trace everything. Everything is in some ledger which cannot be altered, right? So that's the idea. But anyways, just wanted to show you this use case. Now this is where an example of sort of IoT. So the ground stations. 2 years ago, AWS, they announced they are going into ground stations. Last year, Microsoft announced Microsoft Orbital. So they are into ground station. So basically think of ground station, maybe what cloud did to enterprise, right? Where they're like, maybe you guys can get out of your data centers and we'll take care of that and you focus on your application. Like I see similar route here, right? Where the ground stations, where these companies and plus they have incentive, right? They can plug in their cloud to the ground station, and all this information which is coming down can go straight to the cloud, and then you can use different services to do analysis on your data. So, and then not only that, you can do edge computing, right? So you can throw your edge box right where the ground station is. So you don't even have to bring information all the way into your on-prem or cloud. You can just do your computation right there where the ground station is. So I think this is an area emerging because the next generation of ground stations will be laser based. So the right now, the radio frequency, it's the speeds are not fast, right? So but with laser communication, this will be like faster than broadband. So that's where the fun is going to start in a year or so when we have these laser based ground stations. But there will be challenges also, and I'll talk about that where quantum can. Okay, 5G satellites, IoT. This is where 10 years ago, like I mentioned, we used to work in the smarter planet, smarter city stuff. But at that time, as you know, the systems were not as open, or we didn't have that flexibility, or the systems were, the frameworks were not robust. But today, there's so much out there. So now think about these sensors, right? If you're looking at a smarter city where everything is connected, instrumented, intelligent stuff, the three eyes we used to call at that time. And maybe you're in a remote area and whatever the government stuff you have to go through to get the fiber, why not just beam that up, right? And then beam it wherever you want it to be there. I mean, this is like acting as your backbone from, so I think that this is going to even disrupt the telco industry. So imagine 2-3 years from now when almost every part of the globe is interconnected and you have fast speed networks through, let's say, Starlink, then you will try to find the fastest route to get to your wherever your destination is, whether it's cloud or on-prem. So I think that this is very exciting what the satellites are going to do in this interconnected world, and many use cases like precision agriculture, so many use cases here. Think about the rigs, oil rigs, right? Where they have to send a boat to the rig to put data onto some big drive and bring it down to the shore because the bandwidth is not there. So, and they are big users. The oil and gas industry is a big user of geospatial analysis data. So now you can have data from the rig, you can have data from the satellite smart observation. You can do so many interesting things. So I think this is a very interesting and a huge use case over here. Now, the Earth observation, like I mentioned, right? So these companies like Planet, Maxar, and there are many others coming up. I mean, let me show this picture. This is what the Planet can show you, right? And this is what I guess they're telling us. Imagine what else they have in their next gen of prototypes, what they can see. They can almost see everything, right? So if you have that kind of visibility from the top on the planet, now you can tie this to, look at the industries on the left, right? The crop industry, the crude oil, deforestation, right? Especially when we are, when there are these wildfires or these natural disaster. This is where you need this kind of stuff because your ground network is down. So you have like a edge site, right? It becomes your edge site for firefighters where you can plug in something like Starlink. So you can at least have a live connection, right? And you can get information and you can do analysis. So many cool things. insurance companies, right? The maritime industry. So now the 3/4 of the globe, or 2/3 of the globe is water. We don't have connectivity everywhere, and this is where connecting all your cruise lines and ships and the airplanes when we start flying again, right? All connected at a high speed. So there is an enormous amount of, if you're looking from geospatial analysis, there's a huge industry over here from in terms of space tech. So this year, the three Mars missions they reached, right? One from China, UAE, and NASA, and they'll all be doing some very interesting, cool stuff. And then you probably should update SN9 to SN15 because they just did a successful, right? The launch and bring it back. So there's a lot of stuff happening for the Mars, and these are your extreme edge use cases because of the network latency, right? So almost you have to be fully autonomous if we are talking about Mars, right? And how can this stuff work over there? And then not only that, then there's a whole pipeline of, like, let's say if I'm pushing stuff down the road, right? How I'm managing that, and that's where the whole concept of, and I'll talk about in the next slide about the DevSecOps, DevSec AIOps. We can keep on adding acronym to that concept of pipeline. So in RTMS, right? So I think RTMS will be a very interesting use case for people for IoT and edge computing. So what RTMS is like going back to the moon, this time to stay over there. There is a lunar gateway. They want, it's being built. Basically, lunar gateway, it will be equivalent of International Space Station, but this will be, of course, orbiting the moon. And then there will be data centers on the moon. Now, think about this. You're on the ground, your control centers, everything are on the ground. You have this lunar gateway, and then you have the data centers on the moon. There are astronauts over there. There is rovers, landers. There's like a whole city over there. And you're sitting on the ground, you're pushing up code over there. Now, this is where I think the cube will play an interesting role because that's today's standard platform now. So think about, right? We have a cube platform on the ground. We have a cube platforms running on the lunar gateway, and then we have a cube platform running on the moon, on the data centers. And me as a developer sitting on the ground, we're building application, we're building these AI models or stuff like that, and we're pushing all the way to the orbit and the moon. The latency is not as bad as compared to the Mars, but still, first of all, now many other nations, right, like China is also very, you saw that they launched they're also building a equivalent of International Space Station around the Earth. So they launched their first in 2 weeks ago. So now they also are, want to get to the moon, and other nations. Now, if stuff is there so far away, how do you know, what are the bad actors? Because stuff is autonomous. Are they trying to hack each other and take over while you're sitting here thinking your stuff is all doing its thing, right? So from the computer science, from our cloud things which we have learned over time, this is a very interesting use case for a pipeline of, like, say, DevOps, right? Security ops, AI ops. How do I push my code in this pipeline? How do I know it will be, fault tolerant or network tolerant? How will it work when there is network glitches? And then whatever I push there, is it the same thing which I push there? Do I know the signature of the AI model which I'm running there, and it's not being compromised by some other entity which is around by? So I think we still have 2-3 years, but there's a lot of opportunity here, and this is a huge project. So I will highly recommend look into this, because this is an extreme use case for the edge computing. Okay, last but not least, quantum. So there's a huge buzz about quantum computing now, right? So everybody is in the race. IBM, everybody is, it's just like, I think 20 years ago when we used to hear that Intel came up with this processor and AMD and this, and the speed was keep on increasing. I think you will see for some time same that, the qubits are increasing and stuff like that. quantum, in my opinion, is, this is where you have the optimization kind of problems that you can't solve with today's computers, supercomputers in a given amount of time. And what problems can be harder than stuff happening in the space, right? And this, I think quantum is prime for that. So maybe not right now, but let's see in 2 to 3 years. So for example, quantum communications, right? You probably heard of quantum key distribution, right? How can we do that from the space? China showed that last year between the two sites, how they can do the quantum key distribution. But there are other techniques which are being looked at. Okay, collision avoidance. This is like the traveling salesperson problem, right? So now there are agencies talking about how can we do a cleanup in the orbit of all this debris. So you only have limited amount of fuel, whatever object you are going to send, right? So what is the best route? How can I find the best path to find the most, the debris in that given time? And then this ground station, like I mentioned, the laser-based communication with the satellites coming in future. But the challenge with the laser communication is if you have a bad weather, it's not going to be effective. So if I am, in the low Earth orbit, you are almost moving at 17,000 miles per hour. So you are orbiting 12 to 13 times a day. So while my satellite is zooming around the Earth, right, it's also determining what is the next 3 or 4 best ground stations where I can dump information, right? So how can I optimize that route? So these are the few areas. This summer, we got some postdoctorate folks for quantum to say, just take a look at it. What can be done? I know it's still very early, but let's see what the art of possible is. And I think this is another very area. And just a piece of advice. And if you have young, children who are interested in computer science and stuff, right? Go and start with quantum right now. Skip the classical computer. Go to quantum. And IBM. We have this free program for children. Like if you just type IBM Quantum Qiskit, right? They're quite far ahead. I mean, last year when we did this program for summer for high school kids, we had like 9,000 kids joined from all over the world, right? And I think that's the perfect age, right? High school, just jump into this stuff. And for me, I'm still trying to understand how does this even happen, this quantum computer? But the kids, they will pick up so soon because this is the future. So 10 years from now, we will be talking about quantum in our regular conversation. So, all right, I think that's all I have. So happy to answer any questions.
That was awesome. I have a lot of questions, but I'll actually start asking the questions that came in. Okay, so the first one from Bell, is 5G supposed to be capable of orbital communications?
Yes, there will be satellites which will be 5G enabled. If you just Google it, 5G satellites, they are coming up. So they will have compatibility, yes.
So it's not just on the ground then?
No.
Oh, interesting.
Yep.
Okay, the next question, do the 3 orbits each have different protocols?
No. The most common protocol is a radio frequency, right?
Okay.
But future is all laser based, so it will be light communication.
All right. Okay, question from PG, actually 2 that kind of related. What's the data rate between space station and Earth station, and then what's the latency? Do you know?
I know, but I can't share. But it's
very small.
It's very small. It's very small. But but just to give you an example, so Airbus, the Airbus module from Columbus. The Columbus module is part of International Space Station, and they just sent a new antenna in January, and it's installed now. It's not functional yet. It will give you the broadband speed, so that gives you an idea that what speed is today. But you will have very fast speed in few months.
And it's two-way fast speed, or just okay?
Two-way.
Oh, interesting. All right. Okay, and then last one from Maria. How much influence are optical communications doing in inter-satellite communications? So what influence do optical communications have?
That's a huge use case. So there are companies, they are going to they're already planning to put data centers in the orbit. Now, data centers, yeah. The first time when I talked to those companies last year, I was just laughing. I was like, data center with, think about that weight, a whole rack you're launching up, right? But they are serious, and that whole communication will be laser-based communication. That's what they call like these mega constellations of data center. So if you just Google it, mega constellations for data centers in low Earth orbit, there are at least 4 or 5 companies. Then there is another startup, I forgot its name. They're saying, just like how we built the ecosystem on the ground, they're like, okay, guys, you want to build data centers, go for it. We will take care of the backbone in the orbit. So we will provide that laser-based communication between the satellites. So you focus on the data centers while we focus on a communication. And then the other thing too interesting is there are 2 modes of communication from the low Earth orbit. So as you know, the low Earth orbit is going very fast. So you can't just put a dish and expect you will cache unless you have a mesh of like what Starlink is trying to do. So what these satellites do, and this is where optimization and interesting AI stuff comes in. So if they don't have the immediate route to the ground station, because we don't have ground stations scattered everywhere on the globe, we don't want that, right? So what they can do, they can beam data up to the geo satellite, and geo always have a direct connectivity with your dish. So if you want data immediately right now, they can beam up to geo and give it to you.
Wow. Okay. Oh, very cool. That is awesome. Okay, hang on. Leo, I'm going to bring him on stage. Go for it, Leo.
Yeah, so can you hear me?
Yep.
Yeah, so I'm thinking about that, what all these, so like what this means for the astronomy. So is it possible that we're going to have so many light beam between the Earth and the ground, so many satellites that like one day it's not possible to for the astronomers to see the remote stars, and then they have to move their antenna to the moon or like even to Mars.
Yes, very good question. That's a huge concern now. This concern was not there until Starlink came into the picture, right? So now, because we didn't have, like I said, we only had like 9,000 stuff in last 60 years, and in like last 1 year, we have 5,000 or 1,500 plus satellites, right? So this is the government agencies have to come together, because NASA, everybody is screaming, all the amateur community, everybody is screaming, stop this, right? But you know the world we live in, right? It's not going to stop. They'll keep on putting stuff there. So unless the government steps in, and this is only US, wait for China to start, right? So this is going to get very, and I think like always, right? We always wait for something bad to happen. If God forbid there is a collision in the orbit, then people will scream, oh, no, stop this. Now we have to think about it. But the thing is, there is a thing called Kessler syndrome. But Kessler syndrome, right? So it means if 2 collide, it's going to create 6 debris, and those 6 are going to create further, right? So yeah, it's going to multiply, right, exponentially. So hopefully, they will come to senses and work together. But right now, there is no stopping. Everybody just wants to put their stuff as soon as possible in the orbit.
Yeah, data centers colliding in space.
Yep.
Wow.
and the chips raining, right? So in my backyard, I got this very nice NVIDIA GPU. I'm like, wow,
exactly.
It's pretty cool.
All right, Leo, thank you. All right, so there's some more questions in the chat, in the questions window. So Bill, so if 5G is coming to satellite communications, that'll be a huge improvement. How do you imagine that will change things from satellite?
So first of all, it will change a lot of stuff for us on the ground, right? So again, for example, and that's why we are heading towards this Mayflower ship we'll talk about next time. It's like we want this ship to be like a lab, an equivalent of ISS, right? So basically, it's autonomous. It's floating in the oceans, and then it's communicating through these satellites, very fast connection, and we are just sending payload to it. Since we know you are in this area and we think there is something here, go and run this payload for me, because we have these kinds of sensors on the ship, right? Now the future of autonomous ship. Now think about these oil tankers and all these big container ships. What do? They just go from point A to point B. There, right? And there is not much traffic in the ocean. So we don't have like autonomous cars where you have to watch for 50 different things. So this is a very, I mean, although I don't like to eliminate humans from the job, right? But this is a use case where you can just have autonomous ship rush from Shanghai to Seattle port, just auto mode going, right? So I think in these kind of industries, airline industry, entertainment industry, right? So you are in your, you're in your smart car. I mean, the thing is, since we are having a discussion, right? This concept of autonomous cars, right? I buy a car to enjoy the car to drive. I don't understand this concept of autonomous cars where you just want to sit in something and bite. But the thing is, I think the next generation, since I say like they are born on these smartphones, right? They just want to sit in the car and have an experience. And that's why you need all this fast bandwidth connectivity and smarter homes, smarter cities, right? All the use cases.
Yeah, no, I mean the autonomous ship totally makes sense because one of the reasons supply chain shut down is because so many of the crew are taken out with COVID, right? And so yeah, autonomous ship is not going to have COVID. You just send it out. So,
and then these cranes, right? Which right now, as you know, it's a very tough job. It's a 24/7. I used to work on these smarter container ports in Cartagena in Colombia, where it's with these big cranes. They're actually taking the container up and down, right? And if you have done some reading, it's a full science. It's not like they are randomly picking up the containers and moving stuff, right? It's like, for example, the food, the containers which have food cannot go with the container which has flowers. This is all science. They have these specialized systems which figures out how you put container where. And these guys are like playing joystick, right? You see how quickly they are moving, right? That can be all autonomous. That can be AI driven and picking it up, right? But right now, that guy who goes up, he has to do everything there for next 8 hours. He cannot come down.
He's the AI and machine learning all in one.
All in one. And the precision, right? The way he picks it up and drops on the truck. It's amazing. I mean, it's a very amazing skill they have, how they move it, right? So
Oh, awesome. All right. Okay. Another question. Do you know some investigations about space-based solar power generation, or is it still something hypothetical? Have you heard about this?
I've heard about it. I don't know much deep about it, but I've heard about this. So I can't comment right now. Yes.
Okay. Okay, it's PG again. I don't know if you can answer this one. I guess allowed to. What is the Earth latencies to LEO, MEO, and GEO?
I can Google it for you. How about that? It's I think it's
share. That you can
share.
That
I can share. You can see.
Okay, actually, the crane example is interesting because when you combine that with the picture you showed, the high resolution image, right? That's pretty cool. All right, any other questions, folks? I think that was the last one. Otherwise,
but the thing is, to answer the question for latency, right, with the Starlink, but they are claiming to be 20 milliseconds, the same thing which you can do your gaming with their connection. So that's pretty good. I was on the call yesterday with one of our colleagues from Red Hat, and he was on some island, I don't know where he was, and he had the Starlink dish. His download was 300 meg and upload was 45 meg. Not bad.
That's pretty good. Yeah.
Yep.
That's better than most rural areas in the US. Significantly better, even in cities. Yes. And it looks like Jonathan posted a link to a petition on Change.org to it says stop SpaceX Starlink from spoiling outer space for humanity.
Good. Yes.
All right. All right. I'm gonna bring. Leo's back. There you go.
All
right, Leo, go ahead.
Yeah, I just have one last question, and I'm curious about what kind of project are you working on now?
So right now I'm working on a Cube satellite. So I want to launch like IBM's first Cube satellite. And this is purely for nonprofit. So one of my dreams is like when I started working in this area, it is very, very, from logistics point of view, hard to put something in space for, like, let's say, talk about third world countries in South Asia, everywhere, right? If I say, no, I want to launch something, forget it. It's the logistics are very, and then the cost, right? So if you're looking at like let's say a toy kind of a satellite, you're looking at 100K easily, right? 100K is a lot of money back home in other parts of the world, right? So my goal was we want to launch a satellite, and we will have the known suspects like kind of sensors, which is the camera and all that stuff, and I will make that open to every school in the world. So the idea will be you will go on our cloud, on IBM's cloud, and there will be a portal, and you as a, let's say you're sitting somewhere far, far away in Africa, and you have internet connectivity, just send me your ASCII code, right? Just put this text file, upload it. We will send your code all the way up to the orbit on the CubeSat, and it will do its thing and come back with the results for you. So, and because space is an inspiration, it inspires us, right? So if I want to make it open for everybody, that all those nations who can't even dream of sending stuff, let's give them access to space.
So I think that sounds like a like educational project, and so
Yes.
they all kind of sensors are you going to put on the CubeSat?
So there will be, of course, the camera for the Earth observation. There will be there's GPS sensors. There is the magnetometer. There will be like radiation sensor. Then your environmental sensors. There's a total of 15 sensors, and we will publish the API. Just call these APIs, and you will get the information. So make it very easy for any kid in the world to send the code up.
So how many of them are you going to send to the space?
So IBM runs this thing called P-Tech program. So it's a program we have, I don't know, we have hundreds of schools all over the world where we work with them, but I'm opening up to anybody. It will be anyone, right, who has interactivity. So we will see how many, right? It's the thing is we have, since it's like a non-commercial thing, right? The day limit we have is around 4 meg. So that's like close to 2,000 files we can send easily in a day. And we will do computation because it's edge computing. So we are looking right now at the Raspberry Pi, the latest one. And so it will do computation right there and then bring information down. So every day we can serve like 2,000 code.
2,000 CubeSat orbiting around the Earth.
2,000 files, 2,000 people can submit their code every day.
Okay.
Wow, that's cool.
Okay, thank you.
Right, one more person. Hang on, I'm going to bring Bill on stage. That's really cool. Launching the satellite and opening up for school. That's an awesome initiative. When you do that, you should come back and tell us about it.
I will.
Hi, Naeem. Hey,
Bill.
I'm curious. So one of your slides, you were talking about detection of microbes on the space station.
Yes.
Is that for inside the space station or outside? I was going to say microbes couldn't live outside, can they?
No, inside,
Okay.
inside. Yes,
okay.
Inside. Because the reason, so sorry, go ahead.
And maybe, because like I know I asked this question when they were, I think, on NASA's website or something at one point, but I was wondering, is there sound in space? I mean, you can't hear anything in space, right?
No.
Yeah. Okay. I was gonna say it's like it's a vacuum. You can't hear sound. It made no sense. So it's like because I thought they were saying something about they had sound sensors on it too or something, but it must be inside. So it must not
inside.
be. Yeah. Okay.
Yeah,
so
that makes sense.
The thing is, this is because as they are talking about the next generation of like lunar gateway and this time going to stay on the moon. So that's why these DNA kind of experiments are running. And then the other one, growing food. There was a very interesting NASA challenge which just came out, I think 2-3 months ago for globally, that what's the most efficient way of growing food, right? It's because they want to use now this RTMS program, if everything goes well, they want to use this as a stepping base to get to Mars and beyond. So instead of taking a flight from here to Mars, they want to go to moon first, take a break and then go to Mars, right? But I think the most interesting thing is the Starship which we are following, right? If they can make this happen, like I think its flight is now next month. I think it's going to do the orbit thing and then go somewhere in the Pacific Ocean or something.
Cool.
This is huge. I mean, this is only like 200 miles south of me in Austin. So one day I'll go and take a look.
Yearly payloads. I mean, that's impressive. You imagine what all they could bring up there, and then shoot, maybe they can start building something on the moon. Before they go to Mars.
Exactly.
Yeah.
So
Like that's the other thing I had a question about is they were talking about they're doing recordings on Mars. I didn't realize there'd be enough of an atmosphere that you could actually have sound on Mars. So is there sound on the moon? Is there enough atmosphere for that?
Not on the. I
would-
haven't heard about the moon, but on Mars because of the the storms they have. There's Martian storms is famous for that, right? So yes, they do hear voice over there, but I haven't heard about the moon stuff.
Oh, interesting. Yeah, that'd be.
all right. Oh, it looks like Leo had some comments around the sound. So there is a satellite called Plasma Waves in near Earth space, which can convert it into sound. There's also one called Whistler mode plasma waves, which sounds like a whistle. Mars has about 1% of Earth's atmosphere, so in theory, there is sound. Awesome, Leo. You sound like you're a
Cool.
enthusiast, space enthusiast. That's cool. Okay. Thank you, Bill. And it doesn't look like there's any other questions. Actually, I had one. So you mentioned fuel a number of times, right? So
Yes.
they don't have enough fuel. So what is the fuel?
Just a second, since I'm not a rocket scientist.
Yeah. So even when you're moving a satellite, or you said when you need to maneuver it, you don't want to do that because of fuel. So even there, it's
Propellants, yes.
Really? Okay. Okay. So it's not like a solar power with battery and a Tesla motor.
Not yet. Not yet.
Not yet.
Yes. But eventually, it might be electric in the future. But right now, it's propellant. It has to fire it up to move around. Yeah.
Yeah. Okay. Very cool. Okay, I think that was it. There's no other questions, no comments. Naeem, thank you. This was awesome. This was really fantastic. And when you have new updates and stuff to show, you're welcome back.
I will.
Yeah, and so so I'm gonna end the session here. So you had a hard stop at 7:30 your time, right? So 5:30 our time. So about 8 minutes. So folks, when I end the session, it's gonna take you back into the lounge, and I will be hanging out in the at the IoT table. If you have any questions, especially if you want to speak or volunteer, and otherwise, Naeem, you're welcome to hang out for a little bit. There's specifically a table, and then we'll see you next week for sure. Now I'm even more curious how you're using all this technology for Mayflower.